Here's a video to help you with drawing cyclohexane from the side. So normally when you draw cyclohexane, it would you'd see it and you'd be looking at it as if it were a pancake laying on the floor and you're looking down on it from the top. But notice, the two-dimensional drawing is on the left here, the three-dimensional drawing is on the right. Notice if we take the three-dimensional drawing and we can move it to the side, we look at it from the side, notice that you get this sort of pattern here. That's what it looks like from the side. So let's take a picture of this and see how we can draw that from the side in 2 dimensions. So here we have our cyclohexane ring that we saw in 3 dimensions a second ago, and what we want to do is draw that from the side. So now the hydrogens are going to be just implied. So those white little balls, those are the hydrogens, those are just going to be implied, and we're going to draw the carbons, the black balls, as the ends, the like chinks or the corners on the of lines, as we've been drawing before. So the first step you'd want to do is draw 2 parallel lines, and those lines are going to represent these 2 bonds here. So you draw those 2 parallel lines. Now the line that's on the bottom should go a little further down, so you see how this is on the bottom here. It slants a little more down on that side, and the one that's on top will go a little bit further up. Okay, now notice the side that's slanting down has a carbon pointing kind of up, so I'll draw a little dot there. And the side that is pointing up has a carbon sort of pointing down, so I'll draw a little dot there. And then you just connect the dots. And so that would be at least the carbon skeleton for a cyclohexane viewed from the side. Okay, now notice that, and here let me actually do this. Notice that let's look at this carbon that's sort of pointing up. Notice that the carbon that is going vertical on that, there's one hydrogen, I'm sorry, that's going just straight up on that one. And then there's another hydrogen going sort of a little bit to the side and down. And actually, before we draw that other hydrogen in, let's just look at a pattern here. So you have that one hydrogen going straight up. Look at the next carbon over. The one that's going straight down, the one that's going vertical is going down. Next carbon over, the one that's going vertical is going up. Next carbon over, the one that's going vertical is going down. You see that they're alternating. Next carbon over, the one that's going vertical is going up. These vertical hydrogens, the vertical hydrogens have a technical term called axial. So those are the axial hydrogens. Oh, and then there's one more. This hydrogen back here is going down. So those are axial hydrogens. They're either going straight up or straight down. Okay. Look back at the carbon we started with, this one right here. Notice that if the axial hydrogen, the hydrogen that's going either straight up or straight down, the vertical one, if that's going up, then the equatorial hydrogen, that's the one that's going to the side, is going a little bit down. So here equatorial, that means it's pointing a little bit to the side. So, if the axial is going up, the equatorial is going a little bit down. And because it's equatorial, it goes to the side. Now look at the equatorial next door to that. Next door, it's going a little bit up. Next door to that, the equatorial hydrogen is going a little bit down. Next door to that, the equatorial hydrogen is going a little bit up. And so you notice that they're alternating. The next equatorial is a little hard to see, but you can see back there it's kind of going down. And then here on the next one, it's going up. So that's how you would draw all the positions on cyclohexane. You draw the ring first by drawing two parallel lines. The line that's further down slopes a little further down. On the side that's sloping down, put a dot pointing up. On the side that's sloping up, put the dot pointing down. Connect the dots. And then on the end, you have, that's pointing up, you have an axial position going up, and then it alternates. Next carbon over is down, next carbon over is up, next carbon over is down, next carbon over is up, next carbon over is down. If the axial position is going up, then the equatorial position is going down. And notice that every carbon has one axial and one equatorial group coming off of it. And so just like the axial switched up, down, the equatorial switches. So if that equatorial group at the far right is going down, the next one will be going up. If that's going up, the next one will be going down, up, down, up. Okay, so it'll take a little bit of practice, but that's how you can draw cyclohexane from the side, so that you can see the axial or vertical positions and the equatorial or side positions.